Molecules are formed when atoms are joined together by covalent bonds. To form these bonds, single electrons in the atomic orbitals of the atoms join to form pairs of electrons in molecular or bonding orbitals in the molecule. The shapes of these molecular orbitals depend on which types of atomic orbitals have merged. In this lesson, you will learn about sigma bond and pi bond formation. You will also learn how, in atoms such as carbon, electrons move to different energy levels to create a larger number of atomic orbitals in a process called hybridization. Each hydrogen atom has only one electron. The diagram shows two hydrogen atoms. Click the forward button to see the two hydrogen atoms join to form a hydrogen molecule. In the hydrogen molecule, the two hydrogen atoms are joined by a covalent bond. What is a covalent bond? Answer: a bond formed between two atoms when they share a pair of electrons, one from each atom. When two hydrogen atoms join to form a hydrogen molecule, the atomic orbitals overlap. Click the forward button to see this. The bond formed is called a sigma covalent bond. Click the forward button to see this. The diagram shows the valence shell containing 7 electrons in each of the two fluorine atoms. Click the forward button to see the two fluorine atoms join to form a molecule. The fluorine atoms are joined by a covalent bond. How many electrons are now in the valence shell of each fluorine atom? Answer: 8. Fluorine has the electronic configuration 1s2, 2s2, 2p5. The electron in each atom which forms the covalent bond is in the partially filled 2p atomic orbital. The lower diagrams represent the shape of this p atomic orbital in each fluorine atom. The dot in each shape shows the position of the nucleus. How would you describe the three-dimensional shape of a p atomic orbital? Answer: like a dumbbell. As the covalent bond forms, the two p orbitals overlap. Click the forward button to see this. The bond formed between two fluorine atoms is also called a sigma covalent bond. Click the forward button to see this. Which is the most electron-dense part of this sigma bond? Answer: the part between the two fluorine nuclei. A hydrogen fluoride molecule is formed when a covalent bond joins a hydrogen atom with a fluorine atom. The diagram shows the valence electron shells of hydrogen and fluorine atoms. Click the forward button to see these atoms join to form a hydrogen fluoride molecule. How has the formation of this covalent bond changed the valence electron shells of the hydrogen and fluorine atoms? Answer: they now both have full outer shells of electrons. The hydrogen fluoride covalent bond is formed when an electron in the 1s atomic orbital of the hydrogen atom joins with an electron in a 2p atomic orbital in the fluorine atom to form a shared pair of electrons. The lower diagrams represent the shapes of these 1s and 2p atomic orbitals. Why are the shapes different? Answer: one is an s orbital and one is a p orbital. Click the forward button to see the atomic orbitals overlap. Click the forward button again. Where is the electron density greatest in the molecular orbital? Answer: between the hydrogen and fluorine nuclei. Summary: a covalent bond is formed when two atomic orbitals overlap. Sigma covalent bonds are formed when two s atomic orbitals, one s and one p atomic orbital, or 2p atomic orbitals overlap. Oxygen has the electronic configuration 1s2, 2s2, 2p4. An oxygen atom has 6 electrons in its valence shell. An oxygen molecule contains 2 oxygen atoms joined by 2 covalent bonds, shown by the 2 shared pairs of electrons in the top diagram. The first of these 2 covalent bonds is a sigma covalent bond formed by the overlap of 2 p orbitals. Click the forward button to see this. The p atomic orbitals overlap and merge to form a pi covalent bond. Click the forward button. Click again to see this pi bond form. What is different about the pi bond compared to a sigma bond? Answer: half of the orbital is above the plane of the molecule and half of it is below. What does this difference mean for the pi bond orbital's electron charge? Answer: they have electron charge both above and below the plane of the molecule. An oxygen molecule is often written as O double bond O. Why is this not a good representation of the double bond? Answer: it implies that the two bonds are identical, whereas one is a sigma bond and the other is a pi bond. Summary: a double bond is made up of one sigma bond and one pi bond. The pi bond orbitals have electron charged both above and below the plane of the molecule.